derivative ng velocity natin. So, if we substitute this value right here dito, so tayo mag-a-arrive. We have summation of forces equals to the mass times dv over dt. To simplify this further, cross-multiply natin siya para malipat natin yung dt sa kabila. Summation of forces times dt is equal to m dv. So, ano yung mapapansin na natin dyan? This one, very similar na to dito. All you need to do is apply yung ating upper and lower limits. Kasi basically, this is the force times the change in time. Ito na po yung ating impulse. Yung ating impulse is the force associated with the duration in which that force is applied. Yun na po yung ating impulse. In this one, we can simplify this further again. Kasi this one, the right side ng ating equation, this is a function of velocity. This term is as a function of velocity. Dependent siya sa kung ano yung change in velocity natin. Yun namang ating mass that is constant. Yung mass natin that's constant kahit saan yung particle natin, kahit nasan siya along the path na tinatraverse niya. Yung left side naman ng ating equation, this is a function of time. Whereas yung force natin, it's constant. It's a matter of kung ano yung duration in which this force is applied. Yun nga po yung ating impulse. So simplify natin to further. Sa left side ng equation natin, kasi halos itunod ko, i-apply na lang natin yung upper and lower limits natin dito, which is, kung siya in terms of time, so we have t sub 1 and t sub 2. Kung ano yung variable na gagamitin nyo doon, kung t sub f, t sub i, kung ano kayong bahala doon. And that is equal to mass times, yung ating mass times dv, ano naman yung ating upper and lower limits dito. So in terms of velocity tayo, we have velocity 1 and velocity 2. Or v sub f, v sub i, initial and final velocity sub t. Paano nyo i-derive? So, simplify natin this one. Similar na to dito. So, let's leave it like this one. Let's leave it like this. Pero basically, ang mangyayari lang sa kanya, f times t sub 2 minus t sub 1. The net force, summation of forces times the change in time. So, yung ating namang right side ng ating equation, that is equal to, so ilabas natin yung mass kasi that's constant, it's a matter of cancellation lang. So we have velocity natin and yung ating upper and lower limits, we have v sub 2, we have v sub 1. So apply lang natin yung ating limits. F dt is equal to m v sub 2 minus v sub 1. Okay? Further, pwede natin siyang distribute. F dt equal to m v sub 2 minus m v sub 1. Pwede natin ilipat ito pakabila. Transpose natin. M v sub 1 is equal to summation ng f dt is equal to m v sub 2. So ito na po yung ating general formula. Whereas nandito yung ating initial momentum, plus pala ito. Nandito yung ating summation of all the impulses and equal siya sa ating final moment. Okay? Okay lang so far?
Okay lang po.
Okay. So, pwedeng mag-thumbs up na lang kayo para alam ko na naiintindihan na ninyo and I can move on to the next na mag-discuss ko sa inyo. Ano nga po ba ulit yung ating equation? Isahin natin yung kanyang mga components. Isa-isahin natin yung mga components niya. Forces dt is equal to mass times velocity. This first one right here, this is associated with the initial initial momentum. This one right here, ito naman yung summation ng impulses. And lastly, equal siya sa ating final momentum. Okay? Where tayo dun, class? Clear po tayo dun? Yan. Ngayon, let's say we have a block. Yung ating block, nagkaroon tayo ng applied force P. This will make much more sense kapag nag-apply na tayo ng, kapag ginamit na natin ito in problems, pag nilapatan na natin siya ng numerical values at nag-solve na tayo ng problems. Pero itong ating principle of linear impulse and momentum, again, ang sinasabi sa kanya, it relates to us, or it gives us the ability to analyze and solve problems that gives the relation between velocity, force, and time. Ano? Kasi last time, natatandaan niyo yung ating work, saan ba siya associated? Work is the force along a change in displacement. So kung ito yung ating particle, meron tayong change in position. In this time, kung meron tayong force P, ang sinusukat naman natin is yung time or the duration in which that force P is applied. Let's say this force P is applied at 5 seconds. So after 5 seconds, nandito siya. Again, same force P. So ano po yung impulse na yun? That is the force P associated with the duration in which that force is applied. Sorry, let me take this. Okay. So, analyze natin yung components nitong ating equation. We have the initial momentum. Ano yung components niya? We have yung ating mass and we have an initial velocity. Now, pansinin ninyo. This value right here, this is directly proportional dito sa ating final momentum, di ba? Kasi kung i-analyze natin, if we increase the value of the mass, we can't increase the value of the mass, that is constant. Constant po yan. If we increase the value nitong ating initial velocity, di ba? Lalaki yung value ng ating final momentum. Kasi we have a particle. In motion na siya. Di ba mas malaki yung kanyang final momentum kapag meron na siyang initial motion as opposed to kapag it started from rest? Kaya nga po siya directly proportional. Sunod, we have yung ating summation of all the impulses. Ito naman po ay yung force natin. Let's say we have a force applied. The larger the force applied, so syempre, the higher the final momentum natin. And this one, the time. The longer the duration in which this particular force is applied, the higher the value nitong ating final momentum. So ano po yung sinasabi nitong ating principle of linear impulse and momentum? Ano po yung nakaka-apekto sa final na momentum or the final velocity? The motion associated with the mass nitong ating particle in its final state point. So sinasabi niya na that is the sum between the initial momentum, so kung ano po yung takbo niya initially, plus kung ano pa po yung forces or the net force applied during this particular duration na in-apply yung force. So dun po siya magiging equal sa final momentum po natin. So okay po tayo doon sa explanation na yun. Malinaw naman po tayo doon. Okay lang. Okay. Okay, very good. Sige, Ngayon, let's analyze the units naman natin. Units naman natin, so ano ba yung ating equation ulit? M sub 1, sa ulo nitong equation na to, summation ng forces dt is equal to m b sub 2. For SI units, ano yung ating units associated with mass? We have kilogram. For velocity, we have meters per second. For force, ano yung ating associated with force? We have Newton, and for time, we have seconds. Paano naman po kapag English units tayo? What is the unit for mass associated? What is the unit associated with mass kapag on the English units tayo? Anyone?
Pound po.
Again, ang pinag-uusapan natin ay mass. Don't mistake yung ating pound na ginagamit natin siya as mass. Kasi baka magkamali kayo doon. Usually, yung mass ginagamit natin, i-associate natin siya with force. Kasi we have nga yung ating pound force. Ano ba yung ginagamit natin for mass? Napag-usapan natin last time, we have yung ating system of units natin. We have yung ating, huwag kalimutan, we have yung ating slugs. Yung pounds natin, although pounds siya ay mass, kagaya ng kilogram, right? Pero yun yung kung misconception natin, baka pagkamalian natin yung pag nag-solve tayo ng ganitong problem. Kapag binigyan kayo ng mass, baka binigyan kayo ng value in terms of pounds, baka gamitin nyo agad yun as mass, baka i-multiply nyo pa ng 32.2. So, mali po. Ano, kapag binigyan na kayo ng value in terms of pounds, force na po yun. That is the weight na. Weight na po siya, hindi na po siya mass. Ano? Kasi ano po ba yung ating mass? Slug. Ano po yung ating weight? Slug, feet per second squared. And this one is equivalent sa ito na po yun. Ito na po yung ating pound force. Okay? So, wag pong kakalimutan. Baka malito po tayo doon. Ano? So, slugs, again, that is the value associated natin or the unit natin associated with mass kapag English units. And then, feet per second. Feet per second. Tapos, this one, ito po yung ating pound. Pound force times second. Okay? Malinaw po tayo sa ating units.
Malinaw po.
Okay, very good. So, tandaan po yun, ha? So, yun. Basically, that is the gist of nitong ating, principle of linear impulse and momentum. Ano? Lang naman po siya kasimple. It's a matter of, again, analyzing the relationship between velocity, force, and time. Ano? Kapag nakakita kayo ng problem na may velocity, may force, at time, principle of linear impulse and momentum. Pag nakakita kayo ng problem with velocity, force, and displacement, principle of work and energy. Ano? Ganun lang yung analysis natin doon. And if you want to explore more, kasi basically yung binigay ko sa inyo dito, that is the summary of kung ano yung laman na yung module natin. Yung module natin yung upload ko sa inyong group. Yung group sa inyong Google Classroom. Ano, nandun po yun, 3.5.1 to 3.5.2. That is yung ating impulse and momentum. Ano, and ano pa po ba yung meron natin doon? We have yung ating sample problem for 3.5. Ano, so, ano po yung gusto natin gawin doon? I would like you to answer those problems similarly sa kung paano nyo ginawa yung sa ating 3.1, sa ating Newton's second law of motion. Ano? So, gagawin po natin siya on a piece of clean paper. So, malinis po na papel. Ano? It doesn't matter kung anong gamitin nyo na papel. Basta malinis. Do your work. Solve the problems, complete solution, kung paano yung ating sequence, kung paano yung ating flow, and then iscan natin. Then ipapasa nyo ulit sa akin. The deadline of submission naman po niyan is Monday, 12 noon. Hanggang Monday naman po siya. So, tatlo lang ano yun. Try to accomplish those problems. And again, submission nyo sa Monday. Bibigay ko na lang ulit dun sa group as a classroom yung form for submission. Okay? So, yung ating references, we have again RC Hibler, Dynamics book natin. So, any questions so far bago tayo mag-proceed sa ating next part, which is problem solving tayo? Wala na? Okay lang po? Malinaw po so far? Okay lang? Okay?
Okay lang po.
Okay. 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 Okay, sige. I see the majority naman. Not actually majority, pero meron naman like the thumbs up. How about the rest? Okay lang? I can proceed with the next one. Okay lang? Okay, very good. So, kung may questions naman kayo, you can raise your hands para erase yung question niyo. So, let's start with itong ating sample problem. Basahin natin siya. A 50 kilogram crate is pulled by the constant force P. If the crate starts from rest and achieves a speed of 10 meters per second in 5 seconds, determine the magnitude of P. The coefficient of kinetic friction between the crate and the ground is mu sub k is equal to 0.2. So, analyze natin yung ating problem. So, pakilabas na po na yung mga materials, calculators, yung mga sulatan. So, try to solve the problem as solved dito. Analyze muna natin yung ating problem. So, we have a 50 kilogram crate. Mean to say that is the mass. And SI units po tayo. We have yung ating 50 kilogram mass nitong ating crate. It is pulled by the constant force P. So, ito po yung unknown value natin. Kasi sabi dito, determine the magnitude of P. So, ito yung ating unknown. If the crate starts from rest and achieves a speed of 10 meters per second in 5 seconds. Ano yung sinasabi natin dito? Mahalaga po itong mga statements na ito. Ano? Sabi sa atin, it started from rest. So, if it started from rest at t is equal to 0, the velocity natin or the initial velocity natin, sa buwan natin, that is 0. Ano? It started from rest nga eh. Ano? If the weight starts from rest and achieves a speed of 10 meters per second in 5 seconds, so at t daw is equal to 5 seconds, meron na daw siyang velocity na 10 meters per second. Ano? Meron na daw siyang velocity na 10 meters per second. Ano? Determine daw the value of P, the magnitude of P. Ano? Okay. The coefficient of kinetic friction between the crate and the ground is V sub k is equal to 0.2. So meaning to say, hindi po tayo along a smooth surface. Meron po tayong non-frictionless surface dito, whereas binigyan po tayo ng ating value, yung ating V sub k, coefficient of kinetic friction, 0.2. So meron po tayo dito frictional force. Okay? So okay lang po tayo sa analysis ng problem so far? Okay lang?
Okay lang po, sir.
Okay, very good. Okay, very good. How about the rest? Thumbs up lang tayo. Okay, thumbs up lang tayo para alam natin na nagets ng majority and para makamove on tayo sa sunod natin na part. Okay, let's move on with our solution. So yung papakita ko sa inyo, this is an efficient way to solve itong problem na ito. Kasi through the schematic diagram natin and utilizing the equation itself, may ipakita natin kung ano yung nilalaman itong ating problem. And may ipakita natin ano ba yung mga values na given natin and ano ba yung unknown values na kailangan solve natin. So, pay attention dito kasi this is how I solve this kinds of problem. And possible din po ba siyang gamitin with principle of work and energy? Possible din. However, sa principle of work and energy kasi, yung account natin ng ating network, marami kasi tayo doon pinapakita na problem. Marami tayong pinapakita na tawag dito, marami tayo doon pinapakita na schematic diagrams. Kasi we have, di ba yung ating work, that is the force associated with a change in position. Di ba kapag tayo ay mayroong spring force, iba yung pagsukat natin ng mga displacement. Meron tayo dong sariling reference point. Kapag tayo ay work of our gravitational force or weight, iba din yung ating ginagamit din na So, marami kasi tayo dinodrawing din na schematic. Kaya dito naman, it is just the force associated with time. So dito, mas madali siyang ipakita. Okay? So let's do just that. Okay. Given and schematic. Ano ba yung ating equation? We have, again, initial momentum plus summation ng
Impulse.
Very good. Is equal to final
Momentum.
Pero sa 204 yun, I think 204.
Okay. So, final momentum. So, the way I draw the schematic diagram natin, tsaka pinapakita ko yung mga given natin, ni-utilize ko itong ating equation na to kasi this way, makikita natin yung mga nilalaman itong ating problem. So, try to sundan ako habang sinasolve itong problem natin this way. Ano ba yung ating figure for our initial momentum? Ano ba yung ating values associated with the initial momentum? Mass and velocity lang, di ba? Kasi m times v. Paano natin ipapakita yon? If this is our crate, ito yung ating mass ng ating crate. 50 kilograms. Okay? Sunod, what is the velocity? Sabi nga natin that it started from rest. So from t is equal to 0, velocity natin is equal to 0. Meaning to say, walang velocity po tayo dito. 0 po ito. So this is basically yung figure natin for our initial momentum. Hindi siya gumagalaw initially. It started from rest. Just in the time na in-apply natin yung force from t is equal to 0 to t is equal to 5 seconds, dun lang po nagkaroon tayo ng motion. Ano? So plus, for the same crate, ano naman po ba yung summation of all the impulses natin? Ano naman po ba yung net force natin na in-apply dito sa ating crate? Ano? Ano ba yung ating impulse? That is the net force multiplied by the duration or the change in time. Ano? So ano yung meron sa atin dyan? We need to take into account ano po yung net force natin or ano po yung lahat ng forces na in-apply natin dito sa ating object. So let's start with, syempre yung ating unknown value, yung ating force P. Unknown po natin siya, and that is applied, projecting a, 30 degrees, right? 30 degree angle along the horizontal axis natin. Ano pa yung sinabi sa atin dyan? Since meron tayong frictional force, meron tayong coefficient of kinetic friction, so that is the friction associated with motion. That resists yung ating motion. So, meron tayong pakontra. Kung pakanan tayo, pakaliwa yung ating frictional force. Ano pa? Kung meron tayong frictional force, recall, last discussion natin, frictional force that is equal to the coefficient of kinetic friction times the normal force. We need to take into account then yung ating normal force, which is, that is always perpendicular to the contact surface natin. The normal force natin. And lastly, we have yung ating weight ng ating crate. So ito po yung ating summation of ating net, yung ating forces or the net force natin. And lastly, we need to take into account, kasi diba ito ay force, summation of force times change in time, dt. So ano po ba yung duration naman in which this net force is applied? We have at t is equal to 0, papunta po sa t is equal to 5 seconds. Okay? And lastly, upon application nitong force natin and the initial momentum na meron na tayo, ano po yung kanyang magiging final na set point? Yung kanyang final momentum, again, mass times velocity, so the same mass, constant mass nga po tayo. Hindi po magbabago yan. 50 kilograms. But this time, since nagkaroon na tayo ng application ng force P and nagkaroon na tayo ng initial, wala tayo initial momentum, then nagkaroon tayo ng application ng ating force P, so meron na po tayo ditong velocity. At T is equal to 5 seconds, meron po tayo ditong velocity at state point 2 na 10 meters per second. So, mas clear po ba? Tingnan yung ating problem kapag in this manner. Okay lang po?
Yes po.
Yes po, sir.
So kita natin yung ating mga given, kita natin yung hanapin yung ating unknown in this way kasi in-associate na natin siya with our equation na gagamitin. Let's continue. Solution na po tayo. Ngayon, our motion is associated with the horizontal axis. Yung motion natin, it occurs kasi yung ating motion naman to the right lang. Pakanan. So, yung ating motion, let's try to solve yung ating motion. Pakanan. So, along the horizontal axis, using the same equation, m times p sub 1 plus summation of forces. In this case, kasi along the horizontal axis tayo, f of x tayo. Times d, e, not to forget that, is equal to mv sub 2. Assign natin yung mga given natin dyan. Mass, given tayo at 50 kilograms. Initial velocity, 0. Final velocity, 10 meter per second. Yan. Time natin. Digit time natin, t2 minus t1, that is 5 minus 0. So, given. Yung force natin, nandun yung ating unknown. Kasi we need to acquire the value of the net force, and sa net force natin, doon natin makukuha yung value ng P kapag nag-summation of f of x tayo at summation of f of y. So nandito po yung ating unknown. Okay? So let's try to substitute yung mga values na meron tayo dito. So this one, considered na nga po siya as 0 kasi wala po tayong initial velocity starting from s. So 0 plus So mag-summation ng f of x po tayo. Summation ng lahat ng forces along the horizontal axis. So net force natin is equal to the lahat ng pakanan na force minus lahat ng pakaliwa na force. So isahin po natin. Ano po yung ating pakanan na force? Yung ating P. But that is P kasi it's projected along it's projected 30 degrees along the horizontal axis natin. So siya ay P cosine 30. Huwag niyong kakalimutan po yan. Minus, so lahat ng pakaliwa natin, ano ba yung pakaliwa natin? The frictional force. Ano ba yung frictional force nga po ulit natin? That is mu sub k, which is given, times the normal force. And not to forget, the change in time natin. Ano ba yung change in time natin? Initial minus final. 5 seconds minus 0 seconds. 5 minus 0 or simply 5 seconds. So, given is equal to, mass natin again, 50 kilogram given times velocity natin at state point 2, final velocity, 10 meters per second. So, na po yung unknown na natin dyan. Yung ating unknown value ng P at floating pa rin tayo with the value of our N. So, paano naman natin makukuha yung value ng ating N? Yung ating normal force associated with the forces along the vertical axis. So, kunin naman natin yung ating summation of all the impulses along the vertical axis. So, along the vertical axis. Okay? So, same equation. M v sub 1 plus, in this case lang, summation na po siya ng f of y, very good, times dt is equal to m v sub 2. Yan, isa-isahin natin siya. This one, 0 siya. Again, it started from rest. Ito yung tanong ko sa inyo ngayon. Ito pang right side ng ating equation, ano po yung magiging value niya? Zero. Very good. Bakit 0 din? Kasi di ba yung ating motion associated siya with the horizontal axis? Kasi pakanan lang siya. Hindi siya magkakaroon ng vertical motion. Kasi, bakit po hindi naman po siya mag-elevate? So, meaning to say this, value natin dito is 0. Wala po tayong magiging velocity along the vertical axis. Okay?
Okay ba?
Okay. Clear po tayo doon. How about the rest of us? Okay lang?
Okay.
Okay. Okay, very good. Sige, I'm seeing mga thumbs up. So, sige. Tayo ay proceed. Let's proceed. We are left with the summation of ating forces along the y-axis. On the y-axis. So, ano po ba yung ating summation of the forces along the vertical axis? So, we have, again, yung ating pataas minus lahat ng ating pababa. By ating forces na pataas, we have yung ating normal force and we have yung ating P along the 30 degree angle natin. And ano po yung pababa natin? We have yung ating weight. Yun po yung kailangan lang natin. So 0 plus this one. Summation ng f of y natin, we have P, unahin natin with N. N plus, pataas din na ating P, so P
Sine 30.
30. Okay, very good. Thank you for that. Minus yung ating weight. Kasi pababa na po siya. And that is, ano po yung value niya? That is mass times acceleration due to gravity. 50 kilogram times 9.81 meter per second squared. This one, kilogram meter per second squared, that is associated with force, yung downward force natin, or force, yung ating gravitational force or yung ating weight in newtons. And that is equal to, hindi pa pala. Kasi, multiply pa natin siya with the change in time. Ano ba yung change in time natin? Saan ba? Ano ba yung duration na in-apply yung mga forces na yon? So, ganun pa rin. 5 seconds pa rin. So, times 5 seconds. And that is equal to 0. Itong 5 seconds naman natin ito, we can cancel this one out. Kasi pag dinivide natin both sides with 5 seconds, makakancel out lang din natin ito. Ganun din naman kapag dinistribute natin ito and then sinimplify natin ito, dinistribute natin pa kabila, makakancel out din naman natin itong 5 na ito. Magiging bearing yung 5 seconds natin ngayon. So, let's simplify this kasi we need to get the value of n in terms of t para may substitute natin siya dito. We have 2 equations, 2 unknown. Solve na natin yung value ng ating t. So, simplifying that, we have simply n is equal to, gagawin ko lang dito, since we can cancel out itong 5 seconds na to, sisimplify ko lang ito and transpose pa kabila. So, we have 50 times 9.81 minus p sine 30. So, handa po yung ating mga calculator. 50 times 9.81, that is 490.5. 490.5, and this one is in newtons. In newtons po siya. Plus, minus P, ano ba yung cosine 30? Sine 30. Sine 30, that is 1/2. So, 0.5 P. Let's call this equation 2. Meron tayong value ng ating n in terms of t. Meron tayong equation number 2. Kalimutan natin tawagin ito as equation 1. So, we have 2 equations. We have 2 unknown. Pwede natin substitute itong value nito dito sa n ito to account for the value of t. Huwag malilito dito ha. This one is n, this one is newton. Unit po ito. Huwag malilito. So, substitute equation 2 to equation 1. So, substitute lang po natin t cosine 30 minus, po yung ating coefficient of kinetic friction, 0.2 times this one, n. So, this one, 490.5 P minus 0.5 P times. So, ito multiply natin all of those to 5 seconds. So, huwag kakalimutan isama ito, multiplied by 5 seconds din to. Okay? And that is equal to, ano ba yung right side ng ating equation? 50 times 10. Ilang kita? 500 kilogram meters per second. Okay? So, okay po tayo dun so far. Nakakasunod po. Okay lang?
Opo.
Okay. So, simplify natin ito, simplify natin to, i-apply natin to, i-multiply, i-distribute natin to, and distribute natin to simultaneously. 0.5 times cosine 30. 5 pala. 5 seconds times p cosine 30. So we have here 4.33012719 p. Ano yung unit natin dyan? In seconds. In seconds yun Unit po yun Unit yun. Minus, so ito, multiply natin to, distribute natin to while simultaneously distributing ito. So 0.2 times 490.5 times 5. So we have 490.5. 490.5. Ano yung unit nito? Newtons. Newtons po siya. This one, in newtons din siya. Pero this one, since minultiply natin siya with seconds, so Newton second, or ano ba yung Newton second? Kilogram meter per second squared times second. So makakancel natin yung isang value ng second natin, leaving us with kilogram meter per second. Okay? Lastly, ito naman. Plus, 0.2 times 0.5 times 5. So we have 0.5 p in seconds. Unit niya in seconds. It's equal to 500 kilogram meter per second. So, ano yung gagawin natin dyan? Combine similar terms. This one, in terms of p with the unit seconds. This one in terms of, yung unit niya in terms of kilogram meter per second and whole value siya. Numerical value siya. So, substitute. I-transpose natin ito pa kabila. I-add natin dito. And, ito din, pagsamahin din natin siya. Pagsamahin din natin siya and makukuha natin yung value of p. So we have, pagsamahin muna natin yung values ng p. 4.330127019 plus 0.5. So we have 4.830127019 0.0127019. P, again, unit nga, seconds. Ano? And that is equal to ito. Transpose natin pa kabila. 500 plus 490.5. Sorry. Simplify na natin siya. So 500 plus 490.5, that is 990.5. Pinalki pa yun, ano? Kilogram, the unit, ano? Kilogram meter per second. Meter per second. Okay? So ano na yung matitira sa atin dyan? We have the value of P right here. Yun yung ating ano, di ba? So i-divide natin siya, divide natin both sides with 4.83012 para makuha natin yung ating value ng P. So P is equal to 990.5 kilogram meter per second all over 4.830127019. This one is in seconds. Ano? So ano yung matitira sa atin dyan? Unit analysis tayo. We have here kilogram meter per second divided by second. So that is kilogram meter per second times 1 over second. That is kilogram meter per second squared, which is associated with the value, with the unit of kilogram meter per second squared, that is Newton, which is the unit for force natin, which is yun yung ating force P. Ano? So meaning to say, 990.5 divided by 4.830127019, we are left with 205.0671 in newtons. Ano? So pare-parehas po ba tayo nung napalabas na sagot?
Opo.
So, malinaw din po ba tayo in terms of yung sa ating units? Okay lang din? Okay, very good. Okay, very good. So that is yung ating solution for our problem relating to us with our principle of linear impulse and momentum. Ano? So, any questions? Any questions so far? Yan man? Okay lang po? Okay, very good. So, again, yung ating sample problem 3.5, I think yung file name niya. Kasamahan niya yung latest na modules na binigay ko sa inyo for 3.5.1 and 3.5.2. So, pakisolve po na yun. Magagamit nyo naman doon na solutions or general equation is itong pinag-aralan natin ito. So, try to solve yung problem natin. Anyways, ang pasa pa naman niya ay Monday. Bukas may meeting tayo. So, if medyo may kalituhan kayo, you can try and bukas pag-usapan natin kung ano yung mga yun. Ano pa ba? Bukas, yung ating magiging lesson for bukas is pag-usapan naman natin is angular impulse and momentum. Whereas associated naman tayo, what if yung ating object is not traversing such a linear path but along a fixed axis or meron tayong pivot point. So, that being said, again, meron pa pong questions bago ako mag-dismiss. So, mukhang wala ng questions. So, naintindihan po ba? Naging okay lang po ba yung lesson natin for today? Okay lang?
Okay.
Okay, very good. That being said, ibigay ko na lang din sa inyo yung copy nitong PowerPoint na ito in PDF form. And that being said, okay na. That concludes na po muna yung ating meeting for today. I will see you again tomorrow and pwede na po muna tayo mag-dismiss.
Thank you po, sir.
Thank you po, sir.